Okay, hi there. I'm Han, and it is just another video of me solving randomly code problem. So let's begin. So we need to create a binary tree from the description, right? So we are given an description array here, right? And each element in the description array gonna be another subarray in this format, right? We're gonna have the parent, the child, and the value, right? So we're gonna have the value of the parent, the value of the child, and whether it is a left or a right child. Right. So actually it's pretty simple, right? We can just iterate through the description array and then create the node for um, the parents, right? So let's say we are looking at the first element here. We're gonna create a node, right? A node 20 for the parents, right? And then the left, which is 15, right? Because one is left is the left child of the parent, right? Because it is one, so which means 15 is the left child of 20, right? And we also need to put it in the map, right? We can keep track of the value to um right value to node, right? So we can get the node faster later on, right? So in this case, it's value 20 to node 20, right? And then value 15 to yeah, node 15. Node 15 here, like this. Let's put the map around here, right? So yeah, we just have to create the node first, right? And then we can get the node from the map and then create the relationship based on the is left line, right? So we keep going here, right? 20, we already have 20, right? So we already have 20 here. We already had the node 20 here, right? So we just ignore. We don't have node 17, so we create node 17 in the map, right? Value 17 to the node, right? So after that, uh, we create the node, right? And then this node have no relationship. Oh, sorry. This node is the right child of node 20, right child of node 20, right? Because this is 0, right? And then how do we get 20? We can get the node 20 directly from the map, right? It's O1 constant width, right? And you keep going. So we don't have node 50, so we created, right? Node 20. We already have node 20 here, right? And 20 is the left child of node 50, right? Which is something like this. Okay, next one. We already have node 50. So we create node 80, right? And then 50 gonna be the right child of node 80, right? So node 80, like this. Oh, sorry. 80 is the actually 80 is the right child. 80 is the right child of node 50. I got it messed up here, right? 80 is the right child of node 50, right? Okay, and the last one is node 19, right? And 19 gonna be the left child of node 80, 19. Okay, so we got this map, this the tree here, right? Which is correct. So because we use the hash map to store the value to the node itself, we can quickly get the node from the hash map, right? By doing constant read. So we can do this in ON time. Um, but the problem now is that after we finish creating the node and set up all of the relationship in the of the node, right? Then we need to return the root, right? We need to return the root here. So how do we get the root? Well, in this case, we just have to iterate through the map again, right? And look at every single node value. Um, the root node is gonna be the node that doesn't have any children, right? Right. The root node gonna be the node that doesn't have any children, right? So in addition to um the map, right? We need to also keep track of we need also need a set, right, to keep track of the children. Let's say we saw 15, right? Because the middle uh value gonna be the child value, right? We're gonna store that value, right? 15, right? It is 17, right? It is 20, it is 80, it is 19, right? Right. So this is the it is all of the children value. And as you can see here, 15, 20, 17, 8, 19, 80, right? The only node that doesn't have the only node doesn't that isn't a children of any other node is node 50. Node 50 doesn't have a parent, right? It is not so in other words, node 50 is not a children, it's not a child to any other node. So therefore it is the root, right? So we're gonna iterate through the map, right? This map. So 20, 15, 17, 50, 80, 19, right? So we're gonna iterate through uh each node in the map, right? And we're gonna check if this node exists in the children hash children set. If it doesn't, right, which is not 50 here, then which means this node gonna be the parent, right? So the logic here is actually very simple, right? A parent node gonna be the node that will not be a child to any other node. Okay, so let's code this up. So we're gonna need a map, right? A map equal to new map, and we're gonna need a children set. Okay, so I've said earlier, right at the end, we're gonna iterate through the the map, right? We're gonna look at the node value and the node, right? The key is the node value, and the value gonna be the node itself, right? And then if the children doesn't has the node value, right? Which mean we want to return the node, right? This node is the root, right? And we know that the description will always be valid, so we always gonna be we always have a root, right? And the line of the description will always be larger than or equal to 1. So we always have a root. Okay, so we don't have we never have an empty tree. Okay, so we need to iterate through the map, sorry, the description, right? The first one is going to be the parent value, the next one going to be child value, and the last one going to be the flag is left. Okay, so we need to create a node first, right? If map doesn't have the parent's value, we're gonna create that, right? Parent value is the key. The value gonna be the new tree node of the parent value. Okay. Same thing for the children, the child node. Right. So the first step is to create a node, and the next step is to create a relationship, right? If it's left, it's true, right? We do map.get parent value, right? Dot left. So map.get parent value will return the actual parent node, and we're gonna set the left property dot left equal to the node, the child node, right? Map.get child value will return the child node. Okay, and else it is the right child, right? And then we don't forget to add the child to the set, the child value to the set. So we need to keep track of the child as well, right? So that we can find the root later on. Where the root is gonna be the node that not gonna be the children to any other node. It will be the root node. Okay. So this is pretty much it. We'll give it a try, accept it, and it worked. Thank you for watching.